Alright, hi guys, this is Mr. Parham. I'm back with another lesson in Module 0. We're going to talk about units, measurements, and conversions this time. This will be part 1 of a 2-part video. This is kind of a lengthy lesson, so I want to split it up and make sure we're able to get through everything without rushing. So if you haven't already done so, go ahead and put your phone away and complete the bell ringer in Canvas. Go ahead and pause the video. Once you're finished with that, unpause and come back with us. Next thing we're going to do is just go ahead and, sorry, my cat's down here. I want to make sure he's not getting into anything. Next thing is just go ahead and join the presentation by going to joinpd.com and using the code up here on the top right. So that's HIBKK. Go ahead and type that in. Join our presentation. Pause, come back when you're finished. And then the last thing is go ahead and get out some paper and pencil to write down notes, questions that you may have, and work example problems as we go along. Okay. This step 2 here, that is a mandatory step. So it's important that you do this. That way I can track your progress, give you feedback on any questions that I have you answer and things like that. So go ahead and do that if you haven't already. Okay. So we are still in Module 0, measurement, and this is now section 5, the very last section in this module. Units, measurements, and conversions. Okay. So our objectives for today and for tomorrow, since this is a 2-parter, are going to be to infer or select the correct unit to be used in measurement. We also want to be able to use dimensional analysis to convert between quantities. So basically doing unit conversions is what this boils down to. Okay. All right, and just as a review, you may have learned this in a previous science class, but remember, mass is a measurement that reflects the amount of matter an object contains. So anytime you put something on a balance and you get a measurement back in grams, you're measuring its mass. And mass doesn't change depending on where you're at. So mass of an object is the same whether it's on Earth or underwater or on the moon or whatever the case may be. Okay. Our new vocab for this unit, we're going to talk about what a base unit is. We're going to talk about seconds and meters and kilograms, kelvins, density, what a quantity is, and we're going to talk about what a conversion factor is. So these things may be vocab words that you've seen before, and if not, that's okay. We're going to talk about them today. So here we go. All right, so where do units come from? So in chemistry class, we're going to use the SI system of units, and my pronunciation is going to be way off here, but that stands for Sistema Internacional de Unites. Basically, International System of Units is what it stands for. It's French, and my pronunciation is very subpar. Okay, but it's an internationally agreed upon system of measurements that scientists across the world use. Okay, so it's very important, especially in a science class, that we study these units because this is the language that all scientists speak to one another. Okay, and whenever we talk about units, we have these things called base units. So a base unit is a defined unit in a system of measurement that is based on an object or event in the physical world, and it's independent of other units. So in other words, it's basically like a standard or a reference. So, we'll have like standards of measurement for mass. We'll have like a base kilogram, that's a standard, and that's going to be our base unit and what everything else is compared to. So a base unit is just the defined unit for whatever it is we're measuring. Okay? All right, and there are 5 of them that we're going to look at in this class. There are 7 in total, but there are 5 that we're going to look at in this class. So those are length, which has a base unit of meters, and the symbol that we use to express meters is m. So if you see a quantity written out that's 10m, it's going to be 10 meters of length. Our next measurement that has a base unit is going to be mass. So our base unit for mass is the kilogram, which has a symbol of kg. So if you see 10 kg, it means something has measured a mass of 10 kilograms. Okay. Next is temperature. So whenever we measure temperature, it has a base unit of kelvins. So Kelvin has a symbol of a capital K, not a lowercase k, a capital K. So if we see something like 500 K, that's going to be 500 Kelvin. That's a unit of temperature, right? We're used to Fahrenheit in the United States, but Fahrenheit, we're basically the only country in the world that uses Fahrenheit. There may be a couple of others, but in general, other countries are on board with SI units, and so they're going to be using kelvins or Celsius. The next one is time, which has a base unit of seconds, and then that symbol is just the lowercase s. And then the last one that we'll talk about a little bit later in the semester measures how many. It's a counting unit, and that base unit is moles, and has a symbol of MOL. Okay, so these are our common base units that we'll see a lot in chemistry: length, mass, temperature, time, and quantity, or how many. Okay. All right, so I want you to go ahead and take a second to answer these questions. What SI unit would you use to measure the following? We've just talked about what the different measurements are, so go ahead and talk about what unit you would use to measure the hang time of a punt. A punt is a football term for like just a kick. What unit would you use to measure the height of a giraffe? What about your mass, the temperature outside, and how many sodium atoms there are in a grain of salt? So go ahead and draw or type your responses to these questions. Pause until you're finished, and then unpause once you're done. And I will give you feedback as you type those if we're doing this live via Microsoft Teams. Okay? All right, so here is a table, because SI units, the way they're broken down is we have prefixes. So the base unit is like your standard unit for whatever it is you're measuring. So for example, for length, your base unit might be meters. But what if we're talking about the length of something very, very small? Well, we might use millimeters for that. It's still a unit of length, but it has a prefix out in front of it that just tells you, hey, this is about 1,000 times smaller than a meter, okay? Or if we're measuring the length of something very, very large, like let's say, the width of the United States, or the distance from Carolina to LA, right? So you might use a bigger unit of length, like a kilometer or kilometer, which has a prefix to tell you, hey, this is 1,000 times bigger than a meter, right? So all of these different prefixes in SI make it much, much easier to convert back and forth between different units of length. So what we're used to in the American or imperial system of units is like 12 inches in a foot, or 3 feet in a yard, or 5,280 feet in a mile. But look at how easy standard is. It's all based on multiples of 10. So like there are 10 meters in a decameter, or there are 100 meters in a hectometer, or there are 1,000 millimeters in 1 meter, something like that, right? So they're all based on factors of 10, which just makes it so much easier to deal with. And here are the powers of 10. So kilometer is 10 to the third meters, hectometer is 10 to the second meters, and so on and so forth. Okay. And the way we can remember the order of the prefixes is this little acronym. So King Henry doesn't usually drink chocolate milk. If we go back to our table here, starting from the top, kilo is king, hecto is Henry, and then so on and so forth. So King Henry doesn't usually drink chocolate milk, and that'll tell us the order of our prefixes from biggest to smallest, and it'll just make it easier for us to convert back and forth between different units. Okay? So that is there. You can come up with another acronym if you want, that if this one doesn't just stick. You can come up with another one to help you remember that order, but there it is for you. Okay? So if we're wanting to convert back and forth between different units, this is how we're going to do it. So let me go to the whiteboard here. This is slide number 12. So let me go slide number 12. I need to move my face out of the way. There we go. This is slide number 12. Okay. And if I want to do this conversion, 24.75 kilograms into grams, well, I got to look at where am I going to start. And I'm going to start at the K because my unit that I'm starting with is kilograms. So K for kilo tells me I'm going to start at the K. And then my last unit is grams. And so grams doesn't have a prefix. This is what we call just a base unit. So in order to make this conversion from kilograms to grams, I'm going to start here at the K, and I'm going to move to the U. So I'm going to make my decimal move 1, 2, 3 spots to the right. So if I have 24.75, and I grab that decimal and I move it 3 spots to the right, it's 1, 2, 3, and I put a 0 there, my decimal will end up here. So my final answer would be 24,750 grams. Okay? So this is a smaller unit. Grams are a smaller unit, so my number should be bigger. That's one way you can check. So the smaller unit should have a bigger number at the end. I know that this one was supposed to be a prompt for you to pause and answer, but I wanted to go ahead and show you an example. There are a couple more like this so that you can practice. Okay. So like I said, there's the answer to that one. Go ahead and try this one. Pause and come back whenever you're finished, and the video will go through the example for you. Okay, so do that, pause, come back whenever you're finished. I'm going to go ahead and do it. Alright, so this one was 6,870 milliliters. If you look, I start with liters, which does not have a prefix. So no prefix means I always start at the U for base unit. Remember, all these represent prefixes. The K, HD, and then the DCM all represent prefixes, but the U does not. So liters, no prefix. I'll start at the U, and I'm going to the M for milli. So 1, 2, 3 to the right. And if you see, I took my decimal and I moved it 3 spots to the right. So I got 6870. Okay. All right, so go ahead and try this one. Pause, get your answer in there, and then whenever you're done, unpause and come back. I'm going to go ahead and move on. Okay, and you'll see I started with kilometers. My prefix is a K, which means I start here on this little diagram, and then I'm going to meters, which does not have a prefix. And remember, no prefix means I always end up in the middle where my base unit is. So going from the K to the U, that's 3 to the right. Take my decimal and move it 3 to the right, and I get 1,410 meters. Okay, smaller unit, bigger number. So that's one thing you can always do just to check and make sure your answer makes sense. All right, so what is the difference between mass and weight? Because these two words get thrown around, and I guess kind of interchangeably whenever they shouldn't. So mass is a measurement that reflects the amount of matter, and it doesn't change regardless of where you are in the world. So your mass on Earth is the same as your mass on the moon, is the same as your mass in outer space, is the same as your mass underwater. It just doesn't change. It's just how much stuff are you made of, okay? What your weight is a measure of mass and the force of gravity on an object. So now, weight just basically means how hard does gravity pull on you. You might have heard the phrase, the bigger you are, the harder you fall. And that's a true statement, right? The bigger you are, meaning the more mass you have, the harder gravity pulls you down towards the ground. So weight is just a measure of how hard gravity pulls on you. So if I go to a place where gravity is lower, in other words, if I go to the moon, that means I weigh less. That doesn't mean that I'm made of less stuff. My mass is the same, but my weight would go down, okay? And that even works like if you go on top of Mount Everest. Mount Everest is further from the center of the Earth, and so the amount of gravity pulling down on you is a little bit smaller than it would be if you were like at, let's say, sea level. So even your weight can vary slightly in different places on Earth depending on how high of elevation you're at. So the difference, mass does not change, but weight does depending on where you're at and how strong gravity pulls on you. Okay, so there you go. Weight can change from place to place, but mass is constant. It's kind of summarizing what I just said there. So now I want you to think about what would the effect be on your mass and weight if you were on Mount Everest, the highest point on Earth. I kind of just talked about this, but go ahead and just think about it and put it in your own words. And then think about what would the effect be if you were at the shores of the Dead Sea, the lowest point on Earth. Keeping in mind that gravity is stronger the closer you are to the center of the Earth. So go ahead and pause, think about that, get your answers in, I'll give you feedback. And then we're going to go ahead and move on to the next slide, okay? Alright, so density. Not all quantities can be measured with SI base units. So density is what we call a derived unit. In other words, derived, that word derived just means that it's built from other base units. It's not a base unit itself, but it's built from others. So if you notice something like grams per cubic centimeter or grams per milliliter, well, we said grams was a unit of mass, right? Milliliters or cubic centimeters would be a unit of volume. So if I just multiply or divide base units together to get a new unit, that's called a derived unit. That's what density is. Okay? And density measures the amount of mass per unit volume. So basically, that just means it's going to measure mass divided by volume. So let me go to the whiteboard here, slide number 22. Right? So our base units, density is made up of two of our base units. And those are mass, which has a unit of grams, and length, which has a unit of meters, or in this case, centimeters, right? So if I take length times length times length, I get volume. So that's where this centimeters times centimeters times centimeters equals centimeters cubed. That's where this unit came from, grams per centimeter cubed. So if I want to find density, I'm going to do mass divided by volume. Okay, there's my density formula. So I just wanted to show you where that came from. And if that doesn't make sense, then of course feel free to shoot me a message in whatever platform you're using. Okay, so next slide here is just a video. It's about 3 minutes long. It's a pretty good story of how you can use density to determine what things are made of. It's pretty entertaining. I think it's like a little TED Ed video or something like that. But go ahead and pause this video, go into your slides on Join PD, and just watch this video. Okay, and then once you're done, come back. But I'm going to go ahead and move on. All right, so here's the density equation. Its density is equal to mass divided by volume. So remember, density was a derived unit, grams divided by cubic centimeters. So just looking at those units, you might have been able to guess that it's mass over volume, mass divided by volume. But there it is, okay? There's the equation. Now, I want you to stop and think about these questions. Number one, which weighs more, a pound of bricks or a pound of feathers? Which of these has more weight to it? Go ahead and answer that. And then the second one is, which pile is bigger, a pound of bricks or a pound of feathers? Which one of those takes up more space? So think about these two questions and answer them, and you might see where this is going. But go ahead and answer them. Pause the video, unpause when you're finished, and go to the next slide. Okay. So let's go ahead and do some example calculations for density, because we have a formula for density now. So I'm going to go over here to the whiteboard, and this is slide 25. Okay, so it says a piece of granite rock has a mass of 15.5 grams and a volume of 6.01 cubic centimeters. What is its density? So remembering from previous slides, density is equal to mass divided by volume. Well, let's pick out the information in our problem. So it says the rock has a mass of 15.5 grams. So this right here is my mass. And a volume of 6.01 grams per cubic centimeter. So this right here is my volume. And then it says, what is its density? So I'm solving for density. All right, so I'm just going to plug those numbers in. D is equal to 15.5. Oops, that's not a 5. So 15.5 grams divided by 6.01 centimeters cubed. And then whatever I get in my calculator is going to be my answer. Excuse me, so I don't have my calculator with me right now, but it'll be on the next slide. So the answer that we get to that is 2.58 grams per cubic centimeter. Right, so that's how I would calculate the density of a piece of material if it gives me the mass and it gives me the volume. One thing that you can do is there's this like little shortcut if you don't want to rearrange the formula every time. So we have density is equal to mass divided by volume. But what would happen if I wanted to find the mass given density and volume? Well, I could rearrange the equation and get something like D times V. And then what if I wanted to find volume? Well, I could rearrange the equation again and get M divided by D. And then if you don't want to memorize all three of these though, there's this little triangle. If you just memorize this one, the triangle can give you the other two. And so the way I set up my triangle is M divided by V. It means I'm going to have M on top, V on the bottom, and then I'll put the density in the third spot here. So now the way I use this triangle is if I want to find m, well, I can just cover up m, like if I just cover it up with my mouse cursor. Then I want to find m, so my formula is d times v, because that's what's left. So look, d times v. If I want to find v, cover it up with my mouse cursor or whatever, cover it up, and then I get m divided by d. So that's just how you can use a triangle. It's a nice little shortcut. If you don't want to memorize all three of these formulas. Okay, just know one of them, and then you can fill in your triangle. All right, next. Go ahead and try this one. It says a block of wood is 11 centimeters wide by 5 centimeters long and 3 centimeters high, and it gives you a mass. So what is its density? This one is a little bit tricky, so if you want to stick around for a sec. It doesn't give you a volume, but if you remember like the volume of a cube, if I can draw a cube, something like that, right? If you can remember the volume of a cube, it's length times width times height. So length times width times height is equal to volume. So go ahead and try that one out. Pause. Whenever you're finished, come back, and we'll go over the answer. Okay, so here I go. So if you got 0.584 grams per cubic centimeters on that, awesome job. If you didn't, then maybe go back and see if you can figure out your volume again, and then just remember to do mass divided by your volume. See if you get that. Okay, then go ahead and try this one. Now it's asking you the mass of the iron. So you may refer back a couple slides and use that triangle that we talked about. So find the mass given the density and the volume. Another thing on this one is it gives you two volumes. So I want to talk about the difference there. Okay, it says that you have to start a graduated cylinder with water in it, and it starts with 150 milliliters. Okay, and then afterwards you drop a rock in it, and here's your rock down here, and now your volume has increased to 425 milliliters. So if you want to find the volume of just the rock, then you're going to have to subtract those two. So my final volume minus my starting volume will give me the volume of the rock. Okay, so that's how you would solve that one. So go ahead and do that. Pause. Whenever you're finished, come back. Okay. All right, and then you should have got 2,164 grams. So if you didn't get that, go back and see if you found the volume correctly. Here's your mass, and then to find your, here's your density. To find your mass, you're going to multiply density times volume. Okay. All right, so that is it for this video. Really, I just wanted to get through density for part one. Part two, tomorrow, we're going to focus on converting back and forth between different units and doing what we call dimensional analysis. So be prepared for that tomorrow. But I do want you, before you go, to go and drag your dot to how you're feeling. So if you're feeling pretty good, put it in the green. If you have some questions, put it in the yellow or red. And then we will address any questions that you have if you ask them like via Teams or via Remind or whatever method, okay? So we're going to go ahead and stop there. If you have any questions, again, reach out to me on whatever communication platform is easiest for you. If you want a more immediate response, use Remind. But I'm going to go ahead and sign off. I hope this made sense, and I'll see y'all later.